Good afternoon, all you trig fans. Today's topic is the first day of our new unit on graphing trig functions. We have 6 of them: sine, cosine, tangent, cosecant, secant, and cotangent. These are pictures of them. You don't have to copy these down just yet. We're going to learn to graph them in groups of 2 based on kind of their general shapes. And the first 2 that we're going to be graphing are sine and cosine. Before we get into sine and cosine more detailed today, we're going to talk just briefly about how all trig graphs are what we call periodic, meaning that they repeat each other or repeat themselves after, or I should say across the domain, so across the x-axis. So if you can see here, sine x kind of bubbles up and comes down, and it repeats itself over and over again. If this graph were to continue, it would come back up again and down. Same thing with cosine. It bubbles up, it comes down, it goes back up, it comes back down, and it repeats itself over and over again. Tangent and cotangent are these kind of squiggly lines that look almost like cubic functions. And we can clearly see based on the different sections that it's this basic shape that repeats itself over and over again. Same thing with cotangent. And then cosecant and secant have these almost parabola type shapes, but they occur both at the top and at the bottom. We'll talk about why that happens. But we have a parabola that faces up, and then a parabola that faces down, and then that faces up and faces down, and it repeats over and over again. So again, a periodic function is one that repeats itself across the domain, across the x-axis. So now we're going to talk specifically about how to graph the parent function of sine of x or sine theta. So whenever we have a trig function, our x, what we're plugging into that function, is always an angle measurement. So our x values are going to be different angles that we could plug in to evaluate sine for. And then our y values are going to be what we get when we take the sine of that angle. So to evaluate this, we're going to use, the unit circle here. So we don't like to graph things that are not at integral or coordinate points. So if I start by plugging in my most basic angle, which is 0 degrees or 0 radians, remember on the unit circle, sine is always the y coordinate, so I get an x value of 0 and a y value of 0, meaning that on our graph we're going to have a point right at the origin, 0, 0. If we continue up to 30 degrees, we can see that we're going to get a decimal and another decimal and even worse decimal. So the next angle that we're going to graph is going to be at 90 degrees or pi over 2, where the y coordinate is 1. The same thing happens here in quadrant 2, so the angle that we would graph next is 180 or pi. We get 0 again, and if we continue around our unit circle to 270, we get -1, and then back up to 2 pi, where we started at 0. So you can see that we repeat because we can go around the unit circle infinitely, increasing our angle, meaning if we went all the way around to 360 degrees, but then we continued, that would put us at another 360 plus 90 degrees, or 450 degrees, 540 degrees, plus another 90 degrees is 630, and then a full time around the circle again would put us at 720. But we can see how it's going to repeat itself over and over and over again, because we're going to have the same y values every time we go around the circle at those coterminal angles. The same thing would happen if we went in the negative direction. So that's what creates this periodic or repetitive graph. So we create our table of values from the unit circle, and they look something like this. So whether we measure in degrees or in radians, our x value is always going to be our angle measurement, and our y value is the y coordinate on the unit circle, because that's how we evaluate sine, is using the y coordinate. So we can see, like I said, that we're going to have a point. Well, first we should always label our axes. So along the x-axis, remember, we have our angle measurements, whether it's in radians or degrees. And along the y-axis, I just kind of numbered to 2 because my biggest y value is 1 and my smallest y value is -1. And I just kind of skipped a space just so I could utilize more of my graph that's showing on the screen. That's always kind of the goal when you're creating your own graph, is to maximize the amount of space that you use without going over. It's like the Price is Right of graphing. Anyway, so just so you know where these points are coming from, they're coming from the unit circle. So we have a point at 0, 0. We have a point at pi over 2 or 91. We have a point at pi or 180 and 0 again. A point at 270 degrees or 3 pi over 2, and we're at -1. And then finally 360 degrees or 2 pi, and we're back at 0. So this is how we're creating that wave shape. And remember, we said that it continues no matter how many times we go around the unit circle or if we go in the opposite direction. So I'm going to put this off to the side again so we can see the graph. And that's how we create this repetitive or wave shape. These graphs, this sine graph and the cosine graph that we'll see again in a minute, are very similar. These wave shapes are called sinusoids. Anyway, we connect them and we try to hit as many of the points as possible, though you can see that I didn't hit it exactly. We want the basic shape to be right, so we want it to be a wave, not like points. So we don't want pointy tips here and here at our highest and lowest points. We want rounded curves, and just try to hit as many of the points as possible. That's the basic thing, but I'm going to be looking to make sure that you have these actual points plotted correctly. And that's the parent function for sine of theta, or sine of x. So I mentioned that we're also going to be graphing cosine, and we're going to graph it in much the same way. We get our points from the unit circle. Remember, the cosine is the x-coordinate, but we're going to graph using the same angles because all of the x-coordinates are decimals in between here, so we're really using our quadrant angle. That's 0, 90 or pi over 2, 180 or pi, 270 and 3 pi over 2, and 0 and 2 pi, or 360 and 2 pi, I should say again. But when we refer to our unit circle, we end up creating a table of values that looks like this. Again, whether we measure in degrees or radians, our x is always our angle measurement, and our y, again, we can see only goes from +1 to -1. Okay. So actually, I'll leave this out so we can see. So the first thing that we're doing is, of course, labeling our x and our y axis, making sure that we put angle measurements along our x, and our y just needs to go at least from -1 to +1. So our first point is at 0 degrees or 0 radians and +1. At 90 degrees or pi over 2, we're at 0. At 180 degrees or pi radians, we're at -1. We pop back up to 0 for 3 pi over 2 or 270 degrees, and we finish that period at 2 pi or 360 degrees, back to where we started from. But again, this would repeat itself just like the sine graph over and over again. So after we hit our highest point here, we would come back down to 0 and then continue to head down to -1, and then this would repeat back up here if I were to continue in this direction, or the pattern continues in the same way on the opposite direction, in the negative direction. So once we have our points graphed, again, you just want to kind of create your wave shape and try to include as many of those points as possible. You can see that I kind of missed this one over here, but as long as your points are graphed in the correct spot and you have the right basic shape, that's what I'm going to be looking for. So I should mention that in general, when you're asked to create a graph of any trig function, it will tell you what section of the graph that you need to plot, or if it doesn't specify, you need to make sure that you plot however many points that will fit on the graph So you can't just graph like one little section like this. You have to make sure that you plot every point that will possibly fit, or the problem will specify how many points or what period over which you need to graph. Usually it's going to be to graph from -2 pi to +2 pi, or to graph from like 2 complete cycles or periods. We'll talk more about that in a minute, but but make sure that you pay attention so that you're graphing exactly what you're supposed to. And if no instructions for what section to graph appear, then make sure that you graph every point that will fit on your graph. Okay, the last thing we need to talk about today are the specific vocabulary that is helpful when we talk about graphs of sine and cosine, and actually trig graphs in general. Okay, so this is the graph of y equals sine x or y equals sine theta, whichever variable it is we choose to use. What is graphed is only one period, meaning one section of the graph that is repeated over and over again. This is the parent function. So anytime we cross the x-axis, that's called an intercept, an x-intercept to be specific. Our highest points are called maximums. Our lowest points are called minimums. And maximums and minimums and intercepts occur at every quarter period. So it takes us an entire period to complete one wave of sine. And each point occurs at a quarter period because, if you remember, they came from the quadrant. So every time we turned 90 degrees or pi over 2 radians around the unit circle, that's where we had a point that we could plot. So that vocabulary is important that we understand, that a period is the number of x values or the amount of time that it takes to complete one cycle. One cycle is basically one time around the unit circle. And it gives us specific points called intercepts, maximums, and minimums. Okay. The period for the parent function of sine is always 2 pi because it's one time around the unit circle, which is 2 pi. This next one is the graph of y equals cosine x, and this is the period that it looks like. Notice it looks kind of like a cup, whereas sine, even though they are the same graph, sine is looking at it from, and it looks more like a snake. Cosine, the way it ends up, looks more like a cup shape or something like that. But anyway, they are the same graph, just translated horizontally from each other. We'll talk about that more in the future. But anyway, we have the same points, maximums, minimums, and intercepts, and they occur at every quarter period or every quarter turn around the unit circle. And of course, the full period is the amount of time it takes to complete one of these complete turns around the unit circle, which is 2 pi. And so the quarter periods happen at every pi over 2. Okay, that's it. There's a lot of information in there. Make sure you have jotted down all of the important vocabulary and that you have the parent functions graphed along with the table of values that we use.